Okay, so what we're going to look at is we're going to look at solving certain types of equations, and there's a lot of factoring, okay? First thing I'm going to do is show you something very simple. This is a bigger part of the bigger problem that we're going to learn here. We have this thing called the zero property. This says if A times B is 0, then either A is 0 or B is 0. Now that's very simple. Here's what that means. Okay, if you have two numbers that multiply to give 0, what has to happen? Either one of them has to be, one of the other has to be 0, right? Either that's got to be 0, doesn't matter what that is, or it could be backwards. You could have anything there times 0 equals 0. That's all that says. So if you've got a bunch of numbers multiplied to give 0, one of them has to be 0, okay? All right, so what we do with this is when you're solving these equations of this sort, these are already in a factored form, okay? So what you do with this is since they're already in a factored form, you're going to write this like this. Okay, we just take each factor and set it equal to 0. Is everybody with me here? Okay, so let's write this down. Some of you kind of like spaced out or something. Okay, just do this. Now you can solve these two things in your head. Okay, you can solve this equation. What's the answer to this equation in your head?
0.
What does x have to be? 2. How about this one in your head? -4. Now you can show the steps on that, so you can add 2 to both sides, so you get x equals 2. That would have to be one answer of the problem. Okay. The other one, you could subtract 4 from both sides, so that's x equals -4 like that. Those are the two answers to the problem. So what you typically do is you typically write this in a solution set like that. Now that's a real simple kind of thing to learn how to do. When we check the answer to this problem, you have to check both answers, and it's real simple to check. You can even do this in your head. If let's just start with x equals 2. So if you take the problem that I gave you, and if you just replace x with 2, what you would have is 2 minus 2 there. Then you would have 2 plus 4 there. Now notice what you get is 0 times 6 is 0, so obviously that's right. Agreed? Okay. Now let's check x equals -4. Again, if x is -4, just go back to the original equation. Everywhere you see an x, replace it with -4. So that would be -4 minus 2 times -4 plus 4 like that. Well, what do you have? You have -6 times 0, which is also 0. You see what I mean? So see, the thing is, all we did is we just figured out what made the first factor 0 and what made the second 0. Then it's got to be right. Okay? These are problems, a lot of times they're easy enough to do in your head. So what you really do is you just take the factors and set them equal to 0. Okay, like this. All right, now with this problem right here, the 5 doesn't really make any difference. In fact, if you wanted to, although you don't have to, you could divide both sides by 5, and you would end up getting x minus 0.4 times x plus 0.9 equals 0. Now you can tell me what the two answers are in your head, okay? What would you need to use for x to make this become 0? 0.4. How about this? What would x have to be to make that 0? -0.9, exactly. So your answers, so you can do those in your head, you would just get 0.4, and then you would get -0.9, okay? Anytime that you need to write the step out, the step that you're really doing is you just basically take each factor, set it to 0, and solve each equation. Don't worry about the 5. The 5 doesn't have a variable in it, so it doesn't make any difference on the solution. Now if I add 0.4 to both sides, that's going to give x equals 0.4, and then if you subtract 0.9 here, that's going to give x equals -0.9. Okay, students usually don't have any problem doing these. Okay, this is kind of the last step of the bigger problem that we're going to learn here today. Okay, all right, does that make sense so far to everybody? See, it's already in the factored form. You don't want to multiply anything out. You want to leave it in a factored form. So this one would go like this. Don't worry about the 3. You can just ignore it. You can divide by it if you want to. So then you would have x plus 1/5 times x minus 3/5 is equal to 0 like that then, okay? Then you want to go ahead, now you can just do this in your head. What would have to go here to make that 0? Negative 1/5. How about the next one? 3/5. Okay, so what if it's fractions? So you'd have negative 1/5 there, then you'd have 3/5 there, okay? So you don't have to write the steps. Does that make sense? Okay.
Seems rather simple.
It is rather simple, okay? But what we're doing is we're going to do a problem that's a little more advanced than this, and this is generally the last step on it. Okay, this one's a little harder to do in your head. So what you do with this one is you just take the first factor, okay, that's your first factor, set that to 0, then take your second factor and set that equal to 0. So the second factor is 7y plus 26, and then solve that equation, okay? You'll get the two answers like that, okay? You can do whatever you need to do on this. You can subtract 8 from both sides if you want to do it that way. That's 9y equals negative 8. Then you can divide both sides by 9. So one of your answers is negative 8/9 like that, okay? Second one, you can do the same thing here. You can subtract 26. So that gives 7y equals negative 26. Then if you divide by 7, that gives the second answer is negative 26 over 7, like that, okay? Now what I want to do with this one, I want to check just one answer because I do want you to know how to tell this is right. And let's just check and write this down so that you know how to do this. Let's just check the negative 8/9. So if you can check that one, you should be able to check the other one. So really what you would do is you go back to the original problem, and everywhere you see a y, you're going to replace that with negative 8/9. Okay, and don't let the fractions bother you because they work their way out of the problem anyway. Then the second factor, you have 7 times negative 8/9, and then plus 26 like that. Now you're going to see if that gives you 0. Okay, here's the deal. Look at this right here. What happens to the 9s right there? They cancel out, right? And you don't even have to work out the rest of this. You just see, okay, that's negative 8 plus 8. Who cares what this is? I don't even care what that is because isn't that just 0? And 0 times whatever that is 0. Okay? So you would do the same thing with the negative 26/7. It would just make one factor equal to 0. Okay? All right, let's do this, and I'll let you do some problems, and I'll kind of show you where we're going with this a little bit here. So this one is already factored. And that is a factor. That x is a factor. It does have a variable, so it's important that you set that equal to 0. Okay, and that gives you an answer, 0. And then you take the second factor, and you set that equal to 0, then you solve that. So those are the two equations you're going to solve. This one's already solved. So 0 is definitely an answer to the problem. And then this one, if I subtract 15, you get 3x equals negative 15. Then if you divide by 3, it looks like the answer to that one would be negative 5. So it's the same idea, okay? Now I'm not going to check that one. I was kind of more interested in checking that number 4. So is there any questions about what I'm doing?
Yeah.
Pretty easy, isn't it?
A little bit, but I'm a little confused. So you said take the exponent out, that's on the outside, but then you're using it the second equation, or are you using it this equation?
It's got a variable in it, and what you might be thinking about is like on that number 3, see that 3, I took out the 3?
Yeah.
That's not a variable, that's a number.
Oh, I see.
So it doesn't make any difference. See, if you did 3 and set it equal to 0, that's kind of like, why would I do that, right? Okay, that's a number. But this is a variable, so you do have to set it equal to 0. Okay, you have to, because otherwise you'll miss an answer. Okay, so I'm going to let you do these next 4 problems. Give you a few minutes to do that, and we'll kind of move on to what we're trying to get to here. Now I'm going to check maybe a couple. I'm not going to spend too much time on that, but I do want you to certainly know how to do that. So the first thing on this one that you want to make sense of, see that 2 doesn't matter. You can divide by it if you want to, or you can just ignore it. You don't like take 2 and set it to 0. That's like, that wouldn't make any sense, right? So what you're really doing is you're just doing x minus 8 equals 0. You can do that in your head. That's x equals 8. And then x plus 7 equals 0. That's x equals negative 7. Okay? And then again, just write your answer usually in that set builder like that, right? Okay, that's it. That one you just want to do in your head. Okay, the next one, you got 2y plus 17 equals 0. Well, what's going to happen if you solve the same equation twice? You're going to get the same answer, right? Okay, a lot of you have the answer written twice, but it's the same answer. So what you would do is just subtract 17. Okay, that's going to give 2y equals negative 17. Then divide by 2, so I think we all got that. Now you just write it like this. It's just one answer. Okay, if you wrote it like twice, that's unnecessary. Okay, that's a repeated answer, but you just write it down one time. That's going to give same answer, right? Okay, all right. And then the next one, you're doing like x plus a ninth equals 0, and then x minus 4/5 equals 0. So the answers to this one in your head, that's just negative 1/9. And then this one in your head, you would get x equals 4/5. You don't really have to show any steps on that. If you can do it in your head, just write it out. Okay, so that's how that goes, all right? Now let me, let's see, let's check one answer on this, just one answer. Really all you're doing is, if you checked x equals negative 1/9, what you'd really do is you would replace all these x's with negative 1/9. Okay, and you can do this in your head. Okay, I just want you guys to, a couple of times to make sure that you understand what happens on the problem. So what's the value of this thing? 0. And then what's 0 times whatever that is? 0. See what I mean? Okay, so I mean, it's not really all that necessary to check. It just sort of helps you understand why it works. Does that make sense? Okay, all right. Now the next one, I see students mess up on this one more often than anything else, because they kind of forget to do that b. So that b, you do set that to 0, and that is an answer. And then you also got to do the other factor, b plus 12 equals 0. So what's the answer to that? Negative 12. Okay, so those would be your two answers, would be negative 12 and 0. Okay, yes?
It doesn't matter what order we put the
No.
answers in.
No, I usually put them in numerical order, so it doesn't matter. Okay? Okay, you guys do okay with that? Okay, now, what we're going to do next is we're going to start looking at some problems that require factoring. Now, the reason I did that first is because that's a necessary part of the bigger problem we're going to learn. So what we're going to look at is equations like this. Typically, the variable is going to have a second power. It could have a third or fourth power. It depends on the situation. So anytime that your equation has a power in it, you have to factor it. You have to solve the equation by factoring. And this is what will happen. If your highest power is 2, you'll get 2 answers, although the answers could be the same answer twice. If you have a third power, you'll get 3 answers. If you have a fourth power, you'll have 4, and so forth. Okay, that's kind of a nice thing to know. So what we're going to do with this, the whole key to learning how to do this, is you got to make sure, first of all, one side's equal to 0. I'm just going to focus on that for now. So you always make sure one side's 0. Then you're going to try to go through and factor, okay? When you get into doing your homework on 5.8, this is when you're going to learn how well you know your factoring, okay? What kind of factoring problem is 4k squared minus 25? It's a difference of 2 squares. Good, okay? So you factor this like this. You go ahead and draw your 2 parentheses. So you want to go ahead and do that. Everybody needs to do that. So what are you going to use for 4k squared? 2k and 2k. How about for 25? 5 and 5. And then how do the signs go? Okay, good. So you got to get that factoring down. You got to know what kind of problem it is, and then you finish it up. Now, doesn't that look like the kind of problems you just got through working out? Okay, so that's what you're going to do. You're going to set the first factor equal to 0, and you're going to set the second factor equal to 0, and solve those. Now, with a little practice, you can get to where you can do this in your head. So what I'm going to do on this one is subtract 5, and that'll give 2k equals negative 5. Then if I divide by 2, I'm going to get k equals negative 5 halves. So that would be one of my answers to the problem is negative 5 over 2. Okay. Then I do the same thing with the second equation. Just add 5 to both sides. That's going to be 2k equals 5. Then if I divide by 2, I'm going to get the other answer is positive 5/2. So what I've done is I factored, and then I'm able to get the two answers based on that factoring. That's one of the reasons you're learning factoring, is because you have to learn how to solve different types of equations, okay? Now, when we check the answer, always check in the original, okay? Anytime that you check any equation, don't go to the factored part, go to the original. So let's go ahead and check both of these. Let's start with negative 5/2. So what I'm going to do is I'm going to write down the original problem, which is 4k squared minus 25, and we're going to see if that's equal to 0. And what I'm going to do is I'm going to plug in the negative 5/2, like that, okay? Now, just do this in your head, okay? What's 5 to the second? 25. What's 2 to the second? 4, okay? So if you multiply that out, I mean, you can multiply it out twice, but you can do that in your head. That's a negative times a negative. So what that's going to give is 4 times 25 over 4 minus 25. Can you guys see that it's right? What happens to the 4s? Boom, boom. They cancel out, okay? So then that means that that's going to give 25 minus 25 is 0. So that checks that answer. The other answer would be similar. You'd have to check both. But to me, if you understand what I did there, you're going to understand what I did on the other one, right? It ain't going to be any different, okay? So you just go back to the beginning, and anytime you want to check your answer, you can tell that you can determine if you're correct or not, okay? Okay, any question about anything with that? Okay, most of what we're going to look at on here is going to have a lot to do with factoring. So what I want to focus on these next 3 problems is the first thing that you notice, the highest power is a 2. That means you're going to have to solve this equation by factoring. And the other thing you got to look at is, okay, the teacher was kind enough to give one side equals 0. If it's not the case, then you got to make it so. So really what you're going to do with this one is you're going to factor this trinomial. Now if you look at 9, 24, and 12, all of those have a common factor of 3. 3 divides into all those numbers. So what I'm going to do is I'm going to start by taking a common factor out. So I'm going to write the first step like this. Just have one parenthesis and take the 3 out. Now in your mind you can divide all these by 3 if you want to. Now if you do that, you're going to have a 3d to the second. 24 over 3 is 8d. And then 12 over 3 is going to be plus 4 like that. Okay, so that's how you start. Now, what we can do from here is this is a trinomial, which we've learned how to factor. So that's kind of like a trial and error thing. So I'm going to bring down the 3. Then I'm going to focus on this factoring right here. So that first term, and don't even look at the 3, just ignore that. What you're going to use for 3d squared is 3d and d. Nothing else works, so you just got one possibility. Okay, all right. Now for 4, what are your 2 possibilities? 2 and 2, 4 and 1. So you just try one or the other and see what happens. Let's put a 2 there and let's put a 2 there to get the 4. Okay, now let's look and see if we can get this middle term to add up to 8d. So that's a 2d. That's a 6d. So how do you make that add up to 8d? 2 plus signs, right? You just add those two, positive 2, positive 2. So that would go like that. Okay, so that's your factoring. So you got to have your factoring under control to do these problems, obviously. Now, what do you do to finish the problem up? You just take each factor and do what with it? Set it equal to 0 and solve, okay? You don't pay any attention to the 3. You can divide both sides by 3 to get rid of that if you want to. That's not a variable, so you just ignore it. So what you would do now is you would do 3d plus 2 equals 0. That's your first factor. And then your second factor is d plus 2. So you solve those 2 equations and then you got your answer. Okay, and those equations are simple enough you can do in your head. So subtract 2, that's going to be 3d equals negative 2. And if we divide by 3, one of your answers is negative 2/3. Okay, and then over here if we subtract 2, that gives d equals negative 2. So those are your 2 answers. So step 1, factor. Step 2, set factors equal each other, and then you can always check and verify if you want to. Okay? All right, how's that look?
What did you say step 2 was? I just wanted to-
Factor. Okay, what you always want to do is make sure one side's equal to 0, then factor the left side, and then set each factor equal to 0. That's what we're talking about. Okay, let's take a look at this one. We got 45 and 15. Both of those numbers divide by 15. Okay, 45 divided by 15 is 3. 15 divided by 15 is 1. Is there any other common factor that comes out of that other than the 15? An n, right. You have an m to the first, n to the second. You got to take the one with the lowest exponent out. So you start the problem by taking out 15n. Okay, got one side equals 0. You can do this in your head, or you can divide each term by 15n. So notice that 45 over 15 is 3. N squared over n is n. And then anything divided by itself is 1, so you'd have that. That's your factoring, okay? Now, once you do your factoring, the next step is to take each of your factors and individually set those equal to 0 and solve. So you would have 15n equals 0, then 3n plus 1 equals 0. Solve those two equations correctly, then you got your two answers, okay? So this one you could divide by 15. So that gives n equals 0. Okay, this one you could subtract 1 from both sides. So that's 3n equals -1. And then close off by dividing by 3. So your two answers are -1/3 and 0 like that. Okay? Any questions? Now, one of the things you got to learn how to do is you got to learn what kind of factoring goes with which. So let me go ahead and I'm going to go ahead and do the first step on, I'm going to do 13, I'm going to do the first step on 14 and then let you try to finish 14, and that's probably a good stopping point. So, okay, this is already set equal to 0. So we have a trinomial. Okay, so the first term, you got x squared. So you're going to use x and x. Okay, last term's 8. What are you going to use, 8 and 1 or 2 and 4? 2 and 4. This is a trinomial. So we're going to go 4 and 2 to get that 8. So we got that. And then you can think about the sign. That's a 4x. That's a 2x. So we're trying to get a positive 2x. What has to be what? To get a 2x, which one's negative, the 4 or the 2? Yeah, okay, that's negative, and then the 4 is plus. So you want to make sure you do these problems and get your signs right. So that's a plus and a minus like there. Okay, there's your factoring. Okay, what do you do next? Take each factor, set it to 0. So what we do now is we're going to let that be 0, and we're going to let that be 0. So we'll have x plus 4 equals 0, and then x minus 2 equals 0. What are the two answers? Just do that in your head. What are they? 2 and -4. Good. Okay. When you get down that point, most of the time you'll be able to just finish it in your head. Okay, so we got that. -4 and 2 like that. Now, what's different about number 14? I want to finish up with this problem. What's different? Yeah, one side's not equal to 0. So what you have to do is you need to move the 12 to the other side so one side is equal to 0. And when you do that, you're really subtracting 12 from both sides. So you want to start the problem that way. Okay? Then it's the same as the last problem. So go ahead, and we've just got a couple minutes left there. Go ahead and factor that, and then see if you can figure out the answer. Okay? Just want to make sure everybody's got their trinomials down. If you can factor on this section, you'll do fine. What's the right combination for 12? Are you going to use 12 and 1, 2 and 6, or 3 and 4? 3 and 4, good. Okay, because they're 1 apart. Okay, so you got that. Okay, this inner term is 3x. Outer term is 4x. And you're trying to make that add up to -1. So how do the signs go? +3 minus 4, right? Okay. So you should have for your factoring x plus 3x minus 4. So what are the two answers? -3, +4. Okay? Once you get down to that final step, you're more than welcome to just write the answer. Okay? All right, that'll wrap us up for today then. Bring us next time and print out the 6-1 and 6-2. We won't get the 6-2 next time, but go ahead and get those printed.